For our user registration, we allow the user to provide a URL for their avatar. A more realistic way of doing this would be to allow the user to upload an image. We can do that with Firebase Storage. To get started with Firebase Storage, we can navigate to the Firebase console and click on the Storage tab. Then we can click Get Started. This presents us with the default rules for Firebase Storage. What this says is allow anyone who is authenticated with our application to read and write to any file. We'll change these in just a bit to fit our needs. Next, we need to choose the physical location of our storage bucket. Just like with the Firestore database, you should choose whichever location is closest to your website's audience. If that is unknown, feel free to choose whatever is closest to you. It might take just a second to set up the storage bucket. We'll let it do its thing, and we'll get started in the code. In register.view, we can change the type on the avatar input to file. I'll also remove the vModel, as we'll be handling the file input on the change event. And on change, we can run a method called handleImageUpload. Since the user hasn't registered yet, I don't want to actually upload the file to Firebase Storage. This will help us with the storage rules in a minute and keep unused uploads from bloating our storage if the user bails before finishing registration. Instead, I just want to show the user a preview of the image. That way, they get some good user feedback that the image was indeed uploaded. We can get the image from the event using e.target.files and the index of 0. I'll save it to this .form.avatar. That way, it'll be available on the form for submission. Files is a special JavaScript object called a file list containing all the files that the user chose. We just need the first one since they're only uploading a single image. Then, in order to get a URL that we can use in an image source attribute to display the image, we need to use a file reader. On load of the file that will pass to the reader in just a second, we want to set a data property to the result of the file reader's load event. This means we will need to initialize the avatar preview data property, and I'll just start it out as null. Finally, the last thing we want to do is to tell our file reader to read the avatar as a data URL. With that, we can show the image in the template whenever the avatar preview exists. I'm choosing to place the image inside of the label. That way, if the user uploads the wrong image, they can simply click on the image preview to pull up the file finder again. Which also means we can hide the file input when the preview exists. It's necessary to use vShow here and not vIf. That's because we still want the label to reference a valid file input. That way, the browser knows what to do when we click on the label. Awesome. Let's see how far that gets us. I notice that in the file finder, I am allowed to choose file types other than image. Let's fix that. I'll break up the attributes on this input tag here since they're getting so long. And we can specify what file types to accept by providing the accept attribute. will allow any type of image. Yeah, that's better. Now the non-image files are grayed out and unselectable. I can also select my desired avatar image and see it as a preview. Perfect. Now when the user clicks register, we should actually upload the image to the Firebase storage, and then save the URL of that image to the Firestore database as the avatar. Since we already have the file on the form data, we can take care of uploading the file in the register user with email and password action with the rest of the inputs. The first step in uploading a file to Firebase storage is to get a reference to the root of your storage bucket. Then, we can use the child method to specify the path and the file name of the image to upload. I'll nest these images under an uploads directory to segment all our user uploaded files from any storage we might need internally. Then, a directory that is the same as the user's auth ID. This will help make the avatar writable only by the current user when we create our storage rules in a few minutes. And then lastly, it'll reside in an images directory. This will allow us to validate the file type on the server side, ensuring that the user has uploaded an image. We'll use the file name that was on the uploaded file, prefixed with a timestamp. The timestamp ensures a file name doesn't conflict with another file name that the user has previously uploaded. Then, to initiate the upload, we call the put method, passing it the file. We'll wait for the upload to complete, and then get the URL for the image in order to store in the Firestore. Lastly, we only want to do all of this if the user actually provides an avatar. Now, when we complete the registration process in the browser, our image is uploaded successfully and we see it in all the right places. In the next lesson, we'll secure the images with the Firebase storage rules. Firebase storage has security rules just like Firebase Firestore has for securing the files in our bucket. We can access them under the Rules tab under Storage. The first thing I'll do is remove the boilerplate rule that Firebase gave us out of the box. Now, to define our own rules, we need to target files with a match statement, using curly braces to stand in for variable parts of the file path. Then, we want to allow read to anybody and everybody, since everyone should be able to see any user's avatar. Then, we want to restrict the writing of our image to just the user who uploaded it. Notice here that we can access the authenticated user on the request just as we could with the Firestore rules. Also, user ID comes from the path segment we specified in the match above. While we're here, we'll also ensure that anything uploaded to the user's image folder is in fact an image. We can do that by checking the content type on the resource in the request. And that should do it. Now anyone can view our profile images, but only the user who uploaded it can write to it. That is, modify its metadata or delete it. In this lesson, let's provide the user a way to edit their avatar. We'll do that by making the profile picture here clickable. We can accomplish this using the label and file input trick from the previous lesson. First, I'll wrap the image in the label, and then provide the associated file input. And it'll only accept images, just like before. In this case, we never want the input to actually display, because there's already an existing avatar, so we can hide it with a vShow equals false. While we're in this component, I also want to fix an issue that's been hiding for a little while. Let's add a .prevent to the click event on the cancel button. Without the .prevent here, the form actually submits on the click of cancel and saves as though we clicked save. Not sure when and where that got wonky, but it's fixed now. Anyways, back on the file input, we'll use the change event to handle the avatar upload. Before we define this method though, let's extract the logic in the register user with email and password action that handles the avatar upload into its own action. That way, we can use it for editing the avatar, as well as on the registration page. I'll call the new action Upload Avatar. And it will take in the auth ID and the file to upload. First, we'll just return null if the file isn't provided. Then, we'll make the auth ID optional by setting it to the auth ID in the state if it's not provided as part of the payload. Why can't we just get it from the state every time? Well, because then it wouldn't be usable on the registration page, where the auth ID isn't yet available in the state. Next, we'll paste in the uploading logic from above, changing out variables as necessary. This becomes auth ID. We'll change avatar to file. And finally, get the URL and return it. Now, we can replace the logic in the register user with email and password action with a call to our new action. And that should do it. Back in the profile card editor component, we can now map the action we just created. With that, we're ready to define the method that we called on the onChange of the file input. It will get the file from the event and then call the upload avatar action on it. This gets the file uploaded to Firebase storage, but we also need to save the URL of the new file to the Firestore as the user's avatar. The active user data property holds the data that will ultimately get sent to the Firestore, so we need to set its avatar property to the URL of the avatar that's returned from upload avatar. Great. Let's see how this looks in the browser. When we click on the user avatar, we're able to choose a new image, and then nothing happens. Or at least it looks like nothing happens. If I give it a few seconds just to ensure the upload is complete, and then click on Save to commit my profile changes, sure enough, the profile image is updated. Awesome. With that, the basics are working. Now we just need to provide some better user feedback. We'll do that in the next lesson. In this lesson, let's improve the UI for editing an avatar. The first bit that I want to take care of is to make it more obvious that the user can click on the avatar to update it. I'll do that by overlaying a Font Awesome camera icon on top of the profile image. First, we'll need to import the icon in our Font Awesome plugin and register it. Then, we'll use the icon in the template of the profile card editor. I'll also increase its size using the component's size prop and style it using just a little CSS. Lastly, to position it correctly, I'll wrap it in a div with the class of Avatar Upload Overlay. Also, giving the wrapping p tag a class of Avatar Edit. And finally, I'll throw a few more styles in the style sheet. Nice. Let's see how that looks. Cool. That looks more clickable. Now, let's replace the camera icon with our app spinner while the avatar is uploading. To do that, we can initiate an uploading image data property to false. And then set it to true just before doing the upload. And then back to false again when the upload is complete. Lastly, we'll show the app spinner instead of the icon in the template when uploading image is true. All right, let's check it out. I'll upload a new image, and this time we see the spinner until the upload is complete. The spinner's a bit dark though. Let's make it so that the app spinner component can take in a color prop. It will be a string and default to the color it's already using. But how do we use this? The color is being used in the style tag. Can we bind a rule and a style tag to a component prop? Actually, yes, we can. Well, almost. At the time of this recording, Vue 3.2 was just released, and it provides support for binding component data in the style tag. So the first thing we need to do is update Vue to 3.2. Depending on when you started the course, you might already be at 3.2 or higher. To see what version you have installed, you can look for Vue in packagelock.json. I have 3.0.4 here. If we take a look at the package.json file though, we see that the version of Vue specified is 3.0.0, and it has this little caret in front of it. Not going to lie, versioning with npm confused me for probably longer than it should have, but it's really not that difficult. What this caret is doing is saying any version of Vue that's in the major version 3 is acceptable for this project. Thus, when running npm update Vue, npm will install the latest version of Vue within major version 3. Now, if we inspect the version of Vue in the packagelog.json, you'll see that it's updated. So, there's a quick little lesson on versioning with npm. let's get back to styling the spinner. Unfortunately, the feature doesn't seem to support directly binding props inside the style tag. So, first, let's set a data prop to the color prop. Then, we can use a vbind function in the style tag. Yeah, I agree. That's pretty stinking sweet. Let's provide white for the prop in the card editor and see if it worked. Very nice. The spinner is now white. The last thing we need to do to fix the UI is replace the displayed avatar with the newly uploaded avatar. To do that, we just need to replace the source of the image with the active user.avatar. This works because the active user is initiated to the user prop, so it gets the saved avatar to begin with. But in the handle avatar upload method, we update the active user.avatar for submitting to the Firestore on save. Simple enough. Now, if we check things out in the browser one last time, perfect. And for good measure, let's save and refresh. Let's also try out switching the avatar, but then clicking cancel. Alright, we're good to go. Let's take care of notifying the user when an image upload fails. The easiest way I know to trigger an error from Firebase is to upload a file type that's not allowed. That said, let's temporarily remove the accept attribute on the file input. Then, in the upload avatar action, let's wrap our call to Firebase storage in a try catch. And for now, we'll use the browser native alert function to let the user know that there's an error. Also, I'm choosing to use a more generic error message here instead of using the error returned from Firebase, as it might be confusing to the end user. Now, when I upload a file that's not the correct type, sure enough, I get the error message. But now my avatar is also broken. In the profile editor component, let's only reassign the active user.avatar if we were given back the URL of the uploaded image. To do that, I'll store the return from the upload avatar action into a variable, and then assign active user.avatar to that variable. Or, if the variable is falsy, just assigning the user's avatar back to itself. Now I'll test it out again. I'll add another file that's not an image. We still get the alert, and the old avatar stays in place. Since we have our notifications composable, let's use it now to notify the user of the error instead of using the alert. In auth.js, I'll import the composable. Then, inside of our catch, use the composable to add a notification. Cool. Now, if we check it out in the browser, we get the notification as we'd expect. However, it doesn't really scream something went wrong. To make it more apparent that the notification is an error, let's quickly implement the error type option that we mentioned in passing in the notifications lesson. I want to be able to pass in a type like this. To do that, let's add the type option to our add notification function in the composable. I'll default it to info and add it to the object pushed to the notifications. Then, in the app notifications component, we'll support the new option by adding a type class to the notification. And then, provide a different color left border for the type error. So really, all the type is doing is changing the color of that border. But it effectively lets the user know what type of notification it is. Let's see how that looks now. Okay, cool. I think that works pretty well. Let's go ahead and put the accept attribute back on the file input, since we're done with that testing. In closing, it's worth noting that though this particular error should never be possible, as we do have the accept attribute provided on the input, there are plenty of possible errors that this accounts for. You can see all the possible errors listed in the Firebase documentation. We just used the example we did, as it was the easiest to reproduce. So far, everything is working great for when a user has provided an avatar. But what if they choose not to? If I register a new user and don't provide an avatar, now in the header and the profile and all the other places that we should have an avatar, we have this ugly broken image. Obviously, this is not ideal. Let's provide a generic avatar placeholder for those who don't want to provide their own. I'm going to use this avatar image provided on Wikimedia Commons under the Creative Commons license. It's always important to read and understand the licenses of imagery you use from around the web. In this case, we're free to share and remix the work however we want, so long as we provide attribution by linking to this page, as I've done in the description below. Cool. Now I'll download it and add it to the public directory of our project. I'll also rename it userplaceholder.png. Now, in the Profile Editor component, we can check to see if the avatar is provided. Otherwise, we'll show the placeholder avatar. Sweet. I think that works out pretty well. I could do the exact same thing in all the other places where an avatar is used, but that could become a maintenance nightmare, having to remember to always provide the placeholder as a backup. That's no good. So, let's create a component to take care of that cognitive load for us. I'll call it App Avatar Image. I've prefixed it with app so that we know it's meant to be a reusable component throughout the application. We'll allow the component to take in the source as a prop, and then we'll provide the source to an image tag and default to the placeholder, just as we did a second ago. Then, we can use it inside of the profile editor and remove the placeholder backup. Awesome. The placeholder is still in place, but we didn't have to manually provide it. Now let's switch out the normal image tags in all the other places where the avatar is used with our new App Avatar Image component. I'll start with the navbar, and then the regular profile card. Next, the avatar image is also used in the post list. And lastly, the thread list. Now, over in the browser, if I go check it out in all these different places, sweet, yeah, it's looking good. I'll also create a new thread real quick so that we can see it working in the post list and the thread list. Great. This has made not providing an avatar a real viable option for our users. Believe it or not, sometimes users can't be bothered with providing their own avatar. Let's make it easy for them by allowing them to select a random one. Here, you'll see what we'll be making. On the Profile Edit page, we display a random avatar button. When we click it, the avatar is randomly selected. And we can do this as many times as we'd like. Then on Save, the avatar is saved as the user's avatar. Cool. In order to support this feature, we're going to be using the royalty-free stock image site, Pixabay. Pixabay provides a great selection of images that are free to use anywhere and for anything. Plus, they provide a great REST API for searching through their image database right from our own application. To get started, let's check out the documentation for the REST API. In order to search through the images, we can make a call to this endpoint. And there are a number of different parameters available to customize the request. The only required parameter, though, is the key. This serves to identify the application making the request and allows Pixabay to rate limit its API users so that no one user or application is slamming them with too many requests. In order to get a key, we've got to create an account first. I already have one, so I'll just log in. But if you don't already have an account, feel free to pause the video and register real quick. It's quick, easy, and free. Once I'm logged in, my API key is displayed right there in the docs. Nice. Now I can make an API request. To see an example of what the API returns, let's make a request directly in the browser. I'll use Firefox for this though, as it provides some nice JSON formatting to make the response easier to read. What we get back is a JSON object with a total key, a total hits key, and a hits key. The hits here is really what we're interested in. It provides an array of 20 images, and each image has an assortment of information about it. Cool. There's one more thing that we can add to the URL to get back images related to a certain search term. Let's add a Q parameter, which I assume stands for query, and then provide the search term. I'll use cats. Now, as we look through the images returned, you'll see that they all have the term cat or something similar somewhere in their tags. Great. This is all we need to know about the API in order to get our random avatar generator working. Let's head on over to the code and start working on the UI for our new feature. I'll start by creating a new component. I'll call it User Profile Card Editor Random Avatar.view. Yeah, I know it kind of sounds like a mouthful, but I've prefixed it with User Profile Card Editor, as it will only be used in the Profile Card Editor. Alright, next I'll provide the markup for the button, and also the bit of grayed out text underneath it saying Powered by Pixabay. This part is important, as it's part of the agreement we make with Pixabay by using their API. We need to give them credit where credit is due. Now, we'll add a click handler to the button so that we can make our API request when the user clicks it. In order to get random results, let's make a list of random search terms. These can be literally whatever you want. They can be geared more towards the theme of your application or just any random word. Feel free to copy these from the source code for this lesson, or just come up with a list of your own. Next, we need a way to randomly choose one of these search terms. Let's create a helper function called ArrayRandom to do this for us. First, I'll target a random index in the array by multiplying the length of the array with math.random. And using math.floor to round it to the lowest whole number. Then I'll return the element at that index. Great. Now let's import the helper function and use it to get a random word from our search terms. Now, all that's left to do is to make a request to the API. We can make an API request by using the native browser function fetch. I'll provide the API URL with my key hard-coded in it, as well as the random word. You might think that exposing the API key on the client side like this is dangerous, but in this case, it's not really. The reason is because literally anybody can go grab an API key for Pixabay and get access to the exact same things. So there's really no motivation for anyone to ever steal or abuse anyone else's API key. After the request is made, we'll store the response in a variable and get the return JSON data from the response. Now remember, the response contains a hits property containing 20 different images. Let's randomly choose one of them. And the property that we're really interested in on the random image is the web format URL. This is a medium-sized version of the image with a max width or height of 640 pixels, which will be perfect for our avatar. Next, let's omit this from the component so that we can access it in the User Profile Card Editor to set the image. We'll call the event hit. With that, we're ready to use our new component in the Profile Card Editor. And, on hit, we'll set the active user's avatar to the random image URL emitted from the component. And I can't forget to import the component and register it. Let's try it out in the browser. We'll click on Random Avatar, and that didn't work. That's because the form is submitting. We need to add a .prevent to our button. Alright, cross your fingers. Awesome. Now we've got a random image. However, some of them are a little squished because they're not all exactly square. We can fix that with just a single line of CSS. That did it. And now, when we click Save, the image sticks around because the URL for it has been saved to the Cloud Firestore. This is all looking great, but there is one last thing we need to do. Right now, we're hot linking the random images, and we really shouldn't be. We'll talk about that more in the next lesson. While we've got the random images working, right now we're hot linking them directly from Pixabay. What do I mean by that? If we take a look at the image source in the element inspector, you see that the URL points to the Pixabay servers. This is not something Pixabay wants us doing. In their API documentation, they expressly say returned image URLs may be used for temporarily displaying search results. However, permanent hot linking of images, that is, using Pixabay URLs in your app, is not allowed. This means we're good hot linking the image just for temporary display when we click the random image button. But if the user chooses the image as their avatar, we need to download the image from Pixabay, save it to Firebase storage, and then link to the image in Firebase storage for continuous display of the chosen avatar. Alright, to do this, let's create a method in the user profile card editor component to handle this for us. First, we'll check if the avatar is a randomly generated one. We can do this by checking to see if the URL starts with the Pixabay URL. Then, if it is a randomly generated avatar, we'll use fetch to turn the image into a blob. Before, we passed a file from a file input to Firebase in order to store the image. But since this image didn't come from a file input, the other option is to send it to Firebase storage as a blob. That means that we can now call the upload avatar action and pass it the blob. Also, since blobs don't have file names, like files uploaded with a file input, let's pass a file name as well. And in the action, we can use the provided file name if it exists. Otherwise, we can just continue to use the name on the file. Now, we've uploaded the image to Firebase storage, and we just need to tell the form about the Firebase storage URL. And run our method on save. This time, when I choose a random image and save it as my avatar, When we look in the DevTools, you can see that the source points to Firebase and not Pixabay. Perfect.